Okay, ladies and gentlemen, a few things you have to know. Square root of x is the same thing as x to the 1/2 power. This is not the same thing as this, but how about if I had 1/2 x is equal to 5? How would you do that? Well, you take both sides and you multiply through by 2. So you get x equals 10. Now, what we're dealing with here is like the square root of x is equal to 4, okay? That means we have x to the 1/2 power is equal to 4. Same thing. So instead of multiplying both sides by 2, we wouldn't do that. We would take both sides and square that. Now, I'm showing you two different ways to do this because it's important to know exactly what's happening. If you have the square root of x squared, that would be the square root of x squared, which would be just x. So that's why this becomes that. Now, 4 squared is 16. So that's what we get for our solution there. Now here, this part is still going to be 16, just like it is here. But if I have 1/2 times 2, that's a power of a power. So what's half times 2 over 1? That'd be 2 over 2, which is 1. So that shows you why we did that, because we get x to the first power, which is the same thing as x. The other thing we have to remember is we might have extraneous solutions, which means we have to realize there are a few things we can't take the square root of. We cannot take the square root of any negative numbers. Can't do it. So we have to check those answers that we get to make sure we're not taking the square root of a negative number. Okay, now example number 1, we have the square root by itself on that side. So we have, since this root is by itself on its side, what we can do first is just square both sides. When we square both sides, we get 49, and that's equal to, well, root a plus 10 squared. This would be the same thing as the square root of a plus 10 squared. So this square root and that go away. They're inverses of each other. So we're just left with a plus 10. After that, you subtract 10 from each side. And we get a is equal to 39. And that's what we're going to be doing with the majority of these problems. Now, since a is equal to 39, what we're going to do, and I'm just going to give you a hint that there are no problems on this one. We plug it in. See if we're taking the square root of a negative number. Is not 39, when you plug it in, plus 10. Can we take the square root of that? Yeah, the square root of 49 is 7. So that means our answer is correct. So we just check that to make sure we're not getting a bad answer. That's because that's what we can't have. Can't take the square root of a negative number anymore. So let's do number 3 now. On number 3, let me change this color. We have the square root by itself. So we're going to take both sides and we're going to square both sides. On the left side, we get 100. On the right side, what we end up doing is the square root and the square go away. So we're just left with what's inside. So 3k plus 115. After that, we are going to subtract 115 from both sides. We get negative 15. That's equal to 3k. Then we divide both sides by 3. We get k is equal to negative 5. Now you might be thinking to yourself, we can have a negative answer. We can, because when we plug that in, it would be the square root of 3 times negative 5 plus 115. Now what we're looking for is to make sure what's inside the root is positive. So it'd be negative 15 plus 115. Is that positive? Yeah, it'd be a square root of 100. And is the square root of 110? It sure is. So that answer checks out. It works. Now, I'm going to keep it on the same slide, and I'm going to move down to number 6. Because the first thing we have to do here is get this by itself. Now, this is the exact same thing as seeing something like this. The square root of 4x minus 3 plus 3 equals 8. Now, the first thing you would do with this example is you'd subtract 3 from both sides, and that's the first thing we're going to do here as well. We have to get the root or the rational exponent by itself. So this would be 4x minus 3 to the 1/2 power is equal to 5. Okay, so now to get rid of that, we'd square both sides, just as if we had the square root of 4x minus 3 equals 5. We'd square both sides there. Same thing. And these are inverses of each other. So you're left with 1, which is great. So we just have 4x minus 3, and that's equal to 25. So there we're going to add 3 to both sides. We get 4x equals 28. Divide both sides by 4, thinking ahead. And we end up getting x equals 7. Now, if we were to plug that in, since this is the same thing as square root of that, this would be the square root of 4 times 7 minus 3. Would that be positive? Sure would. So then we're good. Those are the two answers. So I got -5 for 3, and I have 7 for 6. Now, on 5, since the 1/2 or the 7v to the 1/2 power is by itself, you would start by squaring both sides. Here on this one, we had to get rid of that 3 first to get this by itself first. So you have to get the root by itself first before squaring both sides. All right, so now on number 17, similar to number 6 that we just did, you would subtract 9 from both sides first. You get 10 is equal to, and this is basically the same thing as saying square root of n minus 8. So I'm just going to leave it n minus 8 all to the 1/2 power. So now we square both sides, because that'll take care of that 1/2 power. We get 100 is equal to n minus 8. We're going to add 8 to both sides. We get n is equal to 108. All right, now if we were to plug that in, since it's the same thing as the square root of n minus 8, 108 minus 8, that's going to be a positive number, so we would be fine. This is an okay answer. It's not extraneous. Now, big change occurs on numbers 9, 10, 11, and 12. We have roots on both sides, but ladies and gentlemen, these are the easy ones. I promise you that. On number 10, if you have roots on both sides, you just square both sides, because what you're left with is what's inside. This would be 7m, and that's equal to 8m minus 1. No more roots, no problems. So I'm going to subtract 8m from both sides. Get all the variables on one side. I get -1m is equal to -1. Then I'm going to divide both sides by -1. Get m is equal to 1. Now, you can plug that in. What we'd have here is the square root of 7 times 1. That's equal to the square root of 8 times 1 minus 1. Either way, ladies and gentlemen, we'd have positive numbers in each root. So we're good. That's my answer. All right, we're close to getting to the difficult ones here, but we're going to take number 12. We're going to square both sides. We get 2n minus 14 is equal to n minus 4. We're going to subtract n from each side. We're also going to add 14 because, you know, it's March. We can handle that. So this will be n equals, those go away, 10. Okay, and if we plug those in, we get positive numbers for each, because 2 times 10 minus 14, that'll be 6. And then 10 minus 4 will also be 6. So positive numbers there. I'm going to keep my 10 as my answer. Okay, so on number 16, we got a fraction in here, so that's going to be a little bit more fun. When I say fun, I know you don't like that probably, but we're going to square both sides because we got the roots on both sides. When you do that, you get x over 3 is equal to 8 minus x. So what we need to do is get rid of this 3. So we're going to multiply through on both sides by 3. When you do that on the left side, we just get x. On the right side, we get 24 minus 3x. So now I'm going to add 3x to both sides. You get 4x is equal to 24. And we're going to divide both sides by 4. When you do that, you get x equals 6. I'm going to box it, and I'm going to plug it in just to make sure we're okay here. Yep, that'll be positive, and that's going to be positive. And square root of 2 is equal to square root of 2. Good. Now, I'm going to skip to number 17. And it's important, I'm going to show it on the same slide because I want you to know the big difference here. Do we have a root? Sure. The root is by itself. But on this side, we have a variable. So that's why things are going to be a little bit more difficult for this one. Okay? We still have to square both sides. We get b squared is equal to -3 plus 4b. Now, in these instances, we have a b squared. That means you're probably going to end up having to factor. So, in order to factor, we need to get them in standard form, which means we need one side set equal to 0. So what I'm going to do is I'm going to leave the b squared alone over here. I'm going to subtract 4b from both sides. So minus 4b. I'm also going to add 3 to both sides. So my right side is now 0. Now, I know it's been a minute since we've done this, but if we're factoring b squared minus 4b plus 3, what two numbers multiply to a 3 and add up to a -4? Well, you might say 3 and 1, and you'd be halfway there, but you need to make them both negative. So that means b minus 3 and b minus 1 equals 0. Okay, so we do get two solutions. One where b minus 3 is equal to 0, and one where b minus 1 is equal to 0. So that means I add 3, add 3, add 1, add 1. I get b is equal to 3, and b is equal to 1. So I get two solutions. Not so fast. I'm going to go ahead and erase this because we have an issue. All right, I'm going to go ahead and plug each of these in. I'm going to start with 3. If I have 3 is equal to the square root of negative 3 plus 4 times 3, that's going to be fine. I think we could probably work with that. Let's see. So this would be 3 equals square root of negative 3 plus 12. So is 3 equal to the square root of 9? It sure is. So 3 checks out. That one works. All right. Now, plug in 1. See if that one works. Make sure we don't have any extraneous solutions. So this would be 1 is equal to the square root of negative 3 plus 4 times 1. So is 1 equal to the square root of negative 3 plus 4? Yeah, 1 is equal to the square root of 1. So actually both of these answers work in this situation. All right, that's what you need to do with all your answers down here, especially when you factor, to make sure that they both work. Now, down to 19, similar problem. We're going to square both sides. The root's by itself, so we square both sides. We get r squared, and that's going to equal 12 minus r. So once again, I have to move both of these over to the left side. So I have r squared. I'm going to add r to both sides, so plus r, and then I'm going to subtract 12 from both sides. So minus 12, and that's equal to 0. So now what two numbers multiply to a negative 12 and add up to a positive 1? If you say 4 and 3, you're real close, but that 3 needs to be negative. So this is the same thing as r plus 4 and r minus 3. So we get two solutions. One where r plus 4 is set equal to 0, and one where r minus 3 is equal to 0. We'll subtract 4, add 3, add 3. We get r is equal to negative 4, and r is equal to 3. I'm going to pause there real quick and make sure. I'm going to delete some of this work. You guys can always go back and pause if you want to look at the work. But now I'm going to plug them in. See what we have here. So let me start with negative 4. Negative 4 is equal to the square root of 12 minus negative 4. So is negative 4 the same thing as the square root of 12 plus 4? Well, what's the square root of 16? Is it negative 4? No, it's not. So since this doesn't work, then negative 4 is what's known as an extraneous solution. We can't have it. Cannot have it. Now I'm going to try to see if 3 is. 3 works. So is 3 equal to the square root of 12 minus 3? Is 3 equal to the square root of 9? Sure is. So there's my one solution there. That's what you need to look out for moving forward. You got to test both answers out to make sure they both work. Now, I have to pause for a second because the next one's going to take a lot of time. Okay, ladies and gentlemen, so here we go. Is the root by itself? No. So we have to start by adding b to both sides. So on my left side, I have b minus 1. My right side is going to be the square root of 7b minus 17. Now, yes, ladies and gentlemen, we have to square both sides. And this is the unfortunate part. When you do that, the right side is just 7b minus 17. The left side, when you have b minus 1 squared, that's b minus 1 times b minus 1. Which means we have to have b times b minus 1, double distribute here, minus 1 times b minus 1. It's been a minute since we've done this as well. So I get b squared minus 1b minus 1b plus 1. Those two don't go away. They add up, ladies and gentlemen, to negative 2b. So this would be b squared minus 2b plus 1. So now that we've done that, we have to get it in standard form. So I'm going to subtract 7b from each side. I'm also going to add 17 to both sides. So I have b squared minus 9b plus 18 equals 0. Now when we're factoring that, let me go ahead and erase that. What we end up with is what two numbers multiply to a positive 18 and add up to a negative 9. That would be 6 and 3 almost, as long as they're both negative. So what this really is b minus 6 and then b minus 3. That's equal to 0. So I get two solutions. One where b minus 6 equals 0 and one where b minus 3 equals 0. I get b equals 6 and b equals 3. So I have two solutions. I'm going to go back and check to make sure they both work. That's what I need to check. So let me get rid of this arrow because that's distracting. So -1 equals square root. Let me try 6 first. So 6 times 7 and then minus 17. That's and then outside the root minus 6. This is -1 is equal to square root 42 minus 17. What is 42 minus 17? Probably a gross number. So -1 is equal to square root of 25. I'm just going to guess it's 25. Minus 6 is 5 minus 6 equal to -1. It is. Good. So that one works. 1% with that one. Now, we are also going to try 3. See if that works. So it's -1 equal to square root 7 times 3 minus 17 minus 3. So this would be -1 is equal to square root 21 minus 17 minus 3. So this would be -1 is equal to square root of 21 minus 17. That'd be square root of 4. What's the square root of 4? Oh no, hang on. So is -1 equal to 2 minus 3? Well, it sure is, ladies and gentlemen. So that one works as well. All right, so two solutions there. Feeling pretty good about those. All right, and the last problem I'm going to do is number 23, and that's because I like making p's more so than I like making k's. So I'm going to start the roots by itself. So I'm going to start by squaring both sides. So this will be 2p plus 61 on the left side. My right side is going to be p squared minus 2p plus 1. All right, same thing we did in the last one. You take p minus 1 and you multiply it by p minus 1. You have to double distribute. This is what you get. So I'm going to subtract 2p from each side because I'm going to get the left side to be 0. I'm also going to subtract 61 from both sides. And this is what I end up with. 0 is equal to p squared minus 4p minus 60. Okay, so now what two numbers multiply to -60 and add up to a -4? So then you have to know some multiples of 60, some factors of 60. If you say 10 and 6, that's a good thing, but you need to make sure it's -10. So then 0 is going to equal p minus 10 and p plus 6. Okay, so I get two solutions, one where p minus 10 is equal to 0 and one where p plus 6 is equal to 0. So I get p equals 10 and p equals -6. So we have to plug those in, though, to make sure things work. So p equals 10, p equals... So let's try 10 first. I think 10 is going to work out for us pretty well. 2 times 10 plus 61, is that the same thing as 10 minus 1? So this would be 20. Square root of 20 plus 61 is the square root of 81. 9, it sure is. So p equals 10 is a solution. It's a good one. Happy about that one. Last but not least, if I try -6, what do you think? Is it going to work? I don't think it is, but we'll see. 2 times -6 plus 61, and this is going to equal -6 minus 1. Now, you might be able to stop here, but I'm going to keep going. This would be -12 plus 61, and then we have -7. Now, here's the problem. We're taking a square root of something and getting a negative number over here. When we take the square root of anything, it has to be positive. It can't be negative. So this will not work. Can't have it. And I can prove that by saying, okay, well, the square root of 49 is not equal to -7. So that's another reason why that doesn't work. Okay, I did half the assignment, all 12 of those. You're going to do the other 12. Do the best you can. Thank you so much.